This is Pre-Calculus, section 12.1, Day 1 Notes, part 2. So we were just looking at that graph, and we used our calculators to help us calculate the value of the function when x equals 2. And we did that by using the second level calculate key. And this showed us that the function is undefined at x equals 2, right? Because when we asked it to calculate the value of the function at x equals 2, it told us that there wasn't a value, right? But yet what we know from our tables is that the y value should get closer and closer to 0.25 as our x value gets closer to 2. Okay? All right, so now we're going to take a look at another example, and again, we're going to use the calculator to do a little bit of investigating here. In our next example, once again, we're going to put this into the calculator, and when you put this into the calculator, it kind of depends on the model of the TI-84 that you have when you're working with square roots, but because we have a numerator and a denominator, we have to make sure, first of all, that we are parenthesizing that whole numerator. And then some of you will also have to parenthesize the x squared plus 4 under the square root to show that all of that is under the square root. And regardless of the model that you have, if you do that, it's not going to be a problem, okay? So I went ahead and I typed this into my calculator. So this is what it looks like. I've got that parenthesis, and then I've got my square root. Under the square root, I've got x squared plus 4. After the square root, I have minus 2. My parenthesis is closed, and then I have divided by x squared. Okay? So now we're going to look at our table setup, because what we're going to do is we're going to ask the calculator to make a table for us, and we're going to ask it to increase the x values first by 0.01, then by 0.001, by 0.0001, etc. Okay? So the way that we do that is we go to second level, and then above the window key, you will see the table set. So that's what we're going to look at. Second level window, and it says table setup. Okay, so we're going to set our table start to equal 0, which it already is. And then you can just arrow down here, and we're going to do that triangle means change, remember. So we're going to change our table by a value of first 0.01. Okay, so I'm just going to type in 0.01 and hit enter. Okay, and now it's changed that. And we're going to leave the independent and the dependent variable at auto. We'll talk about what the ask key means a little bit later. So now that we know what we want our table to do, now we're going to go and look at the table. Remember, the table is a second level function above the graph key. So we're going to go second level graph, and it makes a table for us. Don't worry about that x equals 0. But as you can see, it's increasing our x values by 0.01. And it looks here like the limit is 0.25. That's pretty clear. So we can go back to our table here, and the limit appears to equal 0.25. Now we're going to go back to our calculators, and we're going to change that increment for our table. So we're going to go back to second level table set, and we're going to arrow down here to change the table by 0.001. And we're just going to type that in, 0.001. And then we're going to go ahead and we're going to look at the table. So second level table. Okay. And you can see your x values, 0.001, 0.002, so it's adding 0.001 each time. And once again, it looks here like our limit is 0.25. Okay. So once again, go back to the calculator, and we're going to change our table increments here to 0.0001. And then we're going to look at the table. And once again, those values appear to be approaching 0.25. Okay. Now we're going to get really tiny. Okay. So we're going to go to second level table set. And we're going to change our table increments to 0.00000001. That was 6 zeros. And then we're going to look at the table. And look at that. Now it says something different. Now it says 0. Okay. Well, the limit here actually equals 0.25. The reason the calculator gives false values is that when x is very small, the value of the square root in our function, the value of x squared plus 4, gets closer and closer and closer to 2. And as it does that, when you subtract 2 from it, that makes the numerator 0, which gives the false function value of 0. Because remember, when we calculate a limit, we're looking at what is our function approaching as the value of x gets closer and closer and closer to a given value. So again, just important to always go back to what is the definition of our limit. The last example that we're going to look at today is probably the most interesting one yet. And here is where we're going to learn how to use that ask mode. Okay, so first of all, we need to plug this function into our calculator, and because we're dealing with a trigonometric function, we're going to have to change our calculator mode to radians. So the first thing that I'm going to do here is I'm going to change my mode and make sure, oh, I already am in radians. Okay, it didn't matter for anything else, but I want to make sure that I am in radians, which I am. So now we're going to go to y equals. We're going to clear out that other function, and then we're going to put in there the sign of pi over x. So sine, and then inside the parentheses, pi is second level above our caret. So pi divided by x, close our parenthesis. All right, so now we've got our function in there. If you want to graph it, this thing looks pretty crazy, okay? So when you look at what it looks like, we'll take a little bit closer look at it in a little while. So this time we're going to go back to that second level table setup, and we're not going to worry about this. Instead, we're just going to arrow down to that independent. Remember, x is always the independent variable, y is always the dependent variable. So we're just going to change this to ask. Okay, so you arrow over to ask and you hit enter. And so what that is going to allow us to do is when we go to second level table, it just lets us put in any x value that we want. So we can type in those 4 x values that we're interested in looking at. So the first one I want to look at is 0.1, and then 0.01, and then 0.001. And finally, 0.0001. Okay? And so it automatically calculates these values for us. So now we can go back here and we can say that based on the information that the calculator gave us, all of these appear to be 0. Okay? So based on the above results, the value of the limit appears to equal 0. However, as we know, things aren't always what they appear to be, right? Because if we go back and we look at the graph of this function, there's something pretty crazy going on there in the middle. And so now we can change our window. Okay, so if we go to window here, and I really want to see what's happening right around 0, because the calculator is telling me that the limit is 0, but I'm not sure that that's actually right. So I'm going to go ahead and I'm going to change my x minimum to -1 and my x maximum to +1. And my y minimum, it doesn't really matter, but just so that I can make my window a little bit smaller here, I'll change that to -5 and +5. And let's just see what this looks like. So now let's take a look at our graph. Okay, And the more that you zoom in, the messier that is going to look. But basically what's happening here is as our graph is approaching 0, it starts oscillating up and down like that. And then on the other side of the equal sign, it does something similar and kind of looks like this. Okay, but the problem is when it actually gets to where 0 is, which is right here, right? The function doesn't settle on a certain value. And so that's the problem, right? When we get to 0 right there in the middle, sorry, I had it on the wrong screen, the function doesn't settle at a certain value. So our correct answer here is that the limit does not exist. Because the graph does not exist at x equals 0. The function never settles at a certain value as our x value approaches 0. If you look here at the picture that I drew, on the left-hand side of 0, the graph is above the x-axis, and on the right-hand side of 0, the graph is below the x-axis. So what we learn from this is that because the graph never settles, because it keeps oscillating and it's above the x-axis and below the x-axis as it approaches 0, the left, we call this the left-hand limit and the right-hand limit, do not agree. So therefore, the limit does not exist. So let's write that down because that's a very important statement. If the left limit and the right limit do not agree, the limit does not exist. Okay, and we're going to continue talking about that in our next section.